Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. So we are going to discuss another lecture of binary tree, right? Hope you're liking the series. So in the previous video we discussed about pre-order traversal, and now it is time for us to look at in-order traversal. In-order traversal. So as a revision, what was pre-order traversal? It was root. After that we explored its left subtree. After that we explored its right subtree. Okay. Now what is in order? Right? In order is just a permutation of it. First we will explore the left part. After that we will explore the right root part, and after that we will explore the right part. Right? So it was root left right here, and it is left root right here. Right? This is the only change between pre-order and in order. Right? So if I try to tell you that what is the in order traversal of this given tree, what will be your answer? So you will start with it. So first you will see left. After you land on 1, you will go towards his left. Okay, 2. After you land on 2, you will go towards his left. 4. So you are from 1, then 2. Then you went to 4. Okay. 4 doesn't have a left. 4 does not have a left. So you will explore 4 first. So write 4. Okay. After 4, you will go to its right. 7. You will write 7. Right. The recursion call finishes for 4. You will go back to 2. You will go back to 2. You will see 2. Write it down. 2 doesn't have a right. So go back. 1. Write 1. 1 has a right. So go towards it. 3. 3 has a left again. Go towards it. 5. 5 have a left. 8. So write 8. Written 8. Now 5. Written 5. 5 have a right. So go towards it. 9. Okay. 5 will revert to 33. So as soon as it reverts 3, write it down. After that, go to 6. Go to 6 because 6 is 3 is right. So sorry, I will not write 6. Sorry for my mistake, right? I will not write 6 right now. I went to 6. I see 6 has a left. So go towards 10, right? 10 doesn't have a left. So I will write down 10, right? And now 10 has a right. So write 11. Okay, 10 has a right. So write 11. After 11, it will come back to 10. 10 will go back to 6. And now I will write 6. Now I will write 6. Now you can see all the nodes have been explored, right? All the nodes have been explored and have been written out. This is my in order traversal. This is my in order traversal, right? So I guess it is quite uneasy to visualize and write down the code, right? So as we discussed about a hack in the pre-order traversal, we'll be discussing a hack in the in-order traversal as well. In the pre-order, we mentioned a dash here, right? But in the in-order, we will do something like this. Mention a dash just below it, right? Just below it. I mention a dash below all the nodes, below all the nodes. But my traversal will start from the same point, that is from here. I will go, 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 go. As soon as I encounter a node, I will write down 4. Okay. Again, 7, right? 2, okay. 1, okay. Going and 8, okay. 5, okay. 9, okay. 3, okay. 10, okay. 11, okay. And 6. It is intersecting here, so 6. Now, it is your duty to match both of these traversals. 4 is matching with 4, 7 with 7, 2 with 2, 1 with 1, 8 with 8, 5 with 5, 9 with 9, 3 with 3, 10 with 11, 10 with 10, 11 with 11, and 6 with 6. So exact in order traversal. This is a hack, guys. Just put a dash down, start traversal, at each intersection, write down the node, and that is your answer, right? And that is your in order traversal, right? Okay. Now, what should we do to write down its code, right? So we are learning to write the code, right? We are learning to write the code. It is not good enough that we just see the algorithm and etc. We need to write the code also, right? So coding, similar to pre-order, it can be done in two ways: recursion or iteration, right? First, we will discuss the easy one, which is recursion. Recursion is still easy, but in iteration, you just need to visualize something. So we will discuss about recursion first. Discussing about recursion, we have the tree. Let me write down the tree again, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As in the pre-order, what was the code for pre-order? We write down, we push back the value of code. We push back or print the value of root value, and then we went towards left and then right. The code for recursion for in order is exactly like, not exactly, but similar to it. What we will do, we will code for in order, we will get a root. Now if our root is not equals to null, only then it is being able to explore. what we will do? First, you have to go towards left. So I will call in order for root left. In order for root left, right? Now, what will I do? I will print the value of root. After the in order of root left is finished, I will print. That is, I will explore the value of this root. So print root value. Now go for right part. Go for right part. So in order of root right. This is the recursion code you need for in order. This is the only recursion code you need for in order. This will give you the exact in order traversal, right? I don't want to explore it more because this has been already explored in the pre-order, so I don't want to explore it more. I just want to move towards the good part of it, which is iteration, iterative code, iterative code. All right. So let me write down the tree again. So let us begin with the discussion of iterative order, right? Iterative code for the in-order traversal. Now, in the case of pre-order, we discussed that we will be using stack, right? We will be using a stack, which is actually correct. We will be using a stack here also. Why? How did we think of stack? So because we know that the recursion uses the data structure of stack only, right? So that means we are going to use stack. Stack is a first approach that we will be using. But in the case of pre-order, it was actually very simple. Why? Because suppose I use this stack, what was our code? We pushed the root. So we pushed one here, right? We popped out one. We have one in our hand. One is not here anymore. And we write down one. We write down one. One has been written. But in the case of in order, I just want to write one first. I want to go to two first, right? That is, I want something like this. That one, I write down two, then after that I go to four, and then I pop out four, I write four, and then I explore two, and then I explore two, right? And then I explore two. But that is a problem, right? Because we don't have, like, we want to store the store the elements into the stack up until their left tree has not been explored, right? So what is the requirement? We want to store elements in the stack. We want to store elements in the stack until their left subtree has not been explored, right? Has not been explored, right? So suppose I use a stack named as 1, right? I push 1 into it. I say that I pop out 1, I will push 2 into it. I will push 2 into it, right? I will pop out 1, I will push 1, and I will push 2, right? After that 4, etc., etc., everything will be done. But how do I realize that its left tree has been explored or not? I want to see that whenever I encounter 1 again, I want to see if its left tree has been explored or not. So what I will do, instead of storing only the nodes in the stack, I will be storing two values. One is node star and one is a bool. What does bool signify? Whether whether left subtree has been explored or not. Whether left subtree has been explored or not. So what I will be doing is, let me rub it down. Right. So what I will be doing is, I will be using a stack. I write down a stack. Now I will push 1 with the value 0. What does 0 indicate? That the left tree has not been explored up till now. Okay. I pop it out. I have 1, 0. 0 indicates the left tree has not been explored. So what do? I popped it out. I will push 1 with 1. What 1 does indicate? That I have explored the left subtree. So write down the one's left node. So go to 2, and because 2's left has not been explored, so with 2 write 0. Pop out 2, so I have 2, 0 in my hand. Pop out 2, 0, and now write 2 with 1. Write 2 with 1. After that, 4 will be written. 4 with 0 will be written. Right? Now 4 with 0 will be written. 4 with 0 will be popped out. Right? And now I can say that I have gone towards the left, but that is null. So 4, 1. Right? Now as soon as I encounter a node 4, 1 whose left subtree has been done, explored. So what I will do? I will write my answer as this node first and then go towards it right. I will not push it again. I will just push the right subtree. 7, 0. Right? 7, 0. Again 7, 0 will get popped out, and then I will write 7, 7 comma 1 into the stack, and then I will see the left, it is not there, so I will not push anything into it, right? Again, after popping out 7 comma 1, I will write down 7 comma 1 here. Then I will pop out 2 comma 1, I will draw it 2 doesn't have a right, and then I will pop out 1 comma 1, I will write 1, and then I will explore 3 with 0, and the same process will be repeated for this tree, and then I will get the in-order traversal. So what does my iterative code look like? So first I have created a stack. I have created a stack. What does stack include? Stack includes a pair of node star and an bool value, right? Let us name it as st. Now, if my root is not null, then st dot push your root node. What is the bool value currently? It is false. That is, left tree has not been explored yet, right? Now, while my stack is not empty, what will I do? I will say node equals to st dot top dot first, because first contains my node star, that is this. And now let's say bool, anything, let's say x equals to st dot top second, right? Now the condition arises if x equals to false, if the left tree has not been done, then st dot push, first do we push node with explore, that true, right? Then if my root left is there, if it is not null, then push it. Then st dot push node left, and because lefts of left has not been explored, so it will be going with false, right? It will be going with false. Also here, after these two operations, I will say st dot pop, right? Okay. Now, if it is not false, if it is true, then that means the left tree has already been explored. So in that case, in the else case, what you will do? You will say print node value and then go towards it, right? Print node value. And now if node right is there, it is node here, okay? If node right is there, then st dot push node right, with the value of false, because it is left also we has to be explored yet, right? Okay, this will give me the loop, and this will give me the printing of the in-order traversal in the iterative manner. You can see we have not used any type of recursion, we are just using a stack. Okay, now there exists another algorithm also, but I don't find it intuitive. I found that as cramming, so I'm not explaining that algorithm. For that, you can check out many videos on YouTube, but this is my approach. I have been using it, I have devised it, I have not learned it from anywhere. So if you like this approach, please give me a thumbs up in the YouTube like section. Okay, now moving on towards the code, right? But please, if you have any doubt, please make sure to comment. I will surely get back to you, right? Okay, let us write down the code now. I will first be writing the recursion code, and then followed by it I will write the iterative code. So vector of int answer first, and now just call the in order. Let us call the helper function, right? And I will send the root there with my answer, right? Now void helper, which is taking my node tree node star root, right, and my vector of int answer sent by reference, so and answer. If my root is not null, in that case first I have to go towards left, so call the helper of root left with answer, it is left here, right? And then push the value, so answer dot push back. What do I push back? The root's value, and then call the helper for roots right, same with answer, right? And then you can simply return, right? All right, this is for the recursion code. Let me return the answer and show you that this is working fine, right? Let us try to compile and run it first. It should run fine for the sample test cases. It is running fine. Let us try it for the submit button also, and it is running fine. Okay, and let me show you the iterative code now. So I will not call this function, I will be leaving this as it is. And now what I will be doing, I will be creating a stack of pair of node star with the boolean value, right? Name it as st. Now if my root is not null, then st dot push, what do I push? The root with the false value. What does false indicate? That the left has not been explored yet, right? Now what I will do, I will say while my stack is not empty, do some things. What are the things? First take out the node. So node star node equals to st.top dot first, and similarly bool x equals to st.top dot second, and now you can simply pop it out because the node has been finished from the stack. Now if x equals to false, that is the left has not been explored, in that case first of all push. So st dot push root with true. Now root with true, and it is not capital F, it is small f, and it is small f here also, and it is small t, so true, right? Okay, after that what I will do, if my root left is not null, if not, it is not root, it is node, sorry. If my node left is not null, in that case st dot push nodes left with, what do I push it with? I will push it with false, right? Now in the else case, if my x is true, that is left tree has been explored, in that case answer dot push back the node's value, and then go towards the node right. So if node right is not null, in that case st dot push, what do I push? Nodes right with the false value, because left subtree of right has also been not explored yet, right? And now I can just simply return my answer. It should run fine. Hope it will work. Let me see. There has been some mistake, guys. Let me see. Okay, it is not node star, it is actually tree node star. Okay, let us run it now. It should run fine, I guess. It is running for the sample test cases. Let's try it for the submit as well. Should work, I guess. Should not give any error. Okay, accepted. So thank you for watching. Hope you have liked the video. Hope you are able to understand the concept, and please follow the binary tree playlist along to learn more concepts also. Okay. So I am signing off. Please stay tuned and keep coding. Thank you. Have a nice day.